Students, dear students, this is very important concept bond order for polyatomic ions from chemical bonding and molecular structure. Example 1. Example 1. Carbonate ion CO3 2 minus ion. This is a polyatomic ion. How can you find out or calculate CO bond order? CO bond order in carbonate ion. For the determining of CO bond order in carbonate ion, we have to write its resonancy forms. Now C double bond O, O, O. So how many resonancy forms existed? That is very important. So CO3 2 minus. Now non-bonded electrons involved in pi bond formation. Then here pi bonded electrons moving towards oxygen. Now double bond will become single bond. Pi bonded electrons moving here negative. It will become double bond. Two lone pairs. One lone pair involved in pi bond formation. Now third resonancy forms. Third resonancy form also possible. Third resonancy form also possible. Suppose this non-bonded electrons involved in pi bond formation, then these are migrating like O, negative charge, double bond O, single bond O minus. Now how many resonancy structures possible here? Three resonancy structures possible. 1, 2, 3. Three resonancy structures possible. Understood? Now you can take two fixed atoms. You can take two fixed atoms. This CO you can take fixed atoms. In all resonancy structures, you can take these two fixed atoms. CO, CO, CO. Now, what is the formula? Bond order of CO. What is the formula? Number of or sum of bonds in between two fixed atoms in all resonancy forms. Okay, sum of bonds in between two fixed atoms, in between two fixed atoms in all resonancy forms by total resonancy forms. So this is the formula. Okay, sum of the bonds in between two fixed atoms in all resonancy forms by total resonancy forms. So now here just observe this one, double bond O, single bond. Now 2 plus 1 plus 1 by total resonancy forms how many? 3. That means 4 by 3. 4 by 3 means 1.33. What is the bond order? 1.33. Understood everyone? 1.33. This is the bond order. CO bond order in carbonate ion. Sum of the bonds in between two fixed atoms in all resonancy forms by total resonancy forms. Fixed atoms we have to take. Understood? Now here another trick also there. Another trick generally how many resonancy forms possible? How can you identify? So double bond first position, double bond second position, double bond third position. You can identify like so. Three resonancy forms possible. First to second to third, three positions. So I hope everyone understood this one. Now moving to second example. Example 2. Phosphate ion. Phosphate ion. PO4 3 minus. Phosphate ion PO4 3 minus. PO bond order we have to calculate in phosphate ion. This is also polyatomic ion. So phosphate ion P double bond O, single bond O, single bond O, single bond O. Okay. So no need to write lone pairs, or otherwise you can write single bond means three lone pairs existed according to Lewis-Dawes structure. Yeah. So now how many resonancy forms possible here? Four. Suppose yes, resonancy. P single bond O minus, single bond O minus. This will become double bond O, double bond O, single bond O minus, single bond O minus. Now suppose non-bonded electrons involved, like, then another resonancy form, another resonancy form. Okay, another resonancy form. Now fourth resonancy form. Okay, fourth resonancy form. Fourth resonancy form. So how many resonancy forms possible? Four resonancy forms possible. Okay, clear? Or otherwise double bond O first position, second position, third position, fourth position. This is one trick actually. Okay. So four resonancy forms possible. Now you can fix, you can take two fixed atoms. You can take two fixed atoms. Yes, you can take these two fixed atoms. PO. Okay. In all resonancy forms, you have to take two fixed atoms. Now PO bond order in phosphate ion. What is the formula? Already I have given above, top side. Total number of bonds. Total number of bonds are sum of bonds in between two fixed atoms in all resonancy forms by total resonancy forms. Now 2 plus 1 plus 1 plus 1. Total resonancy forms how many? 4. Now 5 by 4. Then 1.25 is the right answer. What is the answer? 1.25. Understood? What is the PO bond order in phosphate ion? 1.25. What is the CO bond order in carbonate ion? 1.33. Now moving to third example. Third example. Perchlorate ion. Perchlorate ion. ClO4 minus ion. Perchlorate ion. Perchlorate ion. Now, here how many resonance structures possible? How many resonance structures possible? So here no need to write non-bonded electrons means lone pairs. Directly you can write. For resonancy, we can use double-headed arrow. For resonancy, we can use double-headed arrow. Okay, double-headed arrow. You know, here trick. Remaining all are Cl double bond O. One is Cl single bond O. First position, second position, third position, fourth position. So 4 resonancy structures possible. 4 resonancy structures possible. Understood? Now CLO bond order. CLO bond order. CLO bond order. Sum of the bonds in between two fixed atoms in all resonancy forms by total resonancy forms. So now 2 plus 1 plus 2 plus 2 by total how many? 4. So 7 by 4. 7 by 4 means 1.75 is the right answer. 1.75 is the right answer. Now, and another trick also there, another simple trick also there. What is the trick? Cl double bond O, double bond O, double bond O and single bond O minus perchlorate ion. So for this bond order of Cl single bond O, how can we write here bond order? How can we calculate very simply? So here charge delocalized over all oxygen atoms. That is important. All oxygens are participated in resonancy or not? That is important. Yes, all are participated. Then very simple trick here. Okay, this is the trick. Very simple trick. Okay, very simple trick. What is the simple trick? Here oxygen negative charge, that is delocalized over all oxygen atoms. So all oxygen atoms involved in resonancy. That is important. First thing. So that's why. What is the simple trick? No need to write all resonancy forms now. Okay, no need to write all resonancy forms. So simple trick, sum of the surrounding bonds. Sum of the surrounding bonds. Sum of the surrounding bonds around the central atom by surrounding atoms. Okay. Surrounding atoms. This is simple trick. Okay, sum of the surrounding bonds around the central atom by surrounding atoms. Surrounding atoms. So how many bonds around the chlorine? 7. 2 plus 2 plus 2 plus 1, 7. Surrounding atoms. Surrounding atoms. How many surrounding atoms? 4. So 7 by 4 means 1.75. Simple trick or not? But charge delocalized or not over all oxygen atoms or all surrounding atoms, that is very important. That point we have to identify. Understood or not? So now coming to example 4. Example 4. Sulfate ion. Sulfate. SO4 2 minus ion. Sulfate ion. So SO bond order, how can you identify? So here no need to write all resonancy forms. You can write one structure. You can write one structure. That is enough. You can write one main structure. That is enough. One main structure. So now here charge delocalized over all oxygen atoms or not? Yes, 100%. Then simple formula you can use, sum of the surrounding all bonds by surrounding atoms. Okay, sum of the bonds surrounding the central atom by total surrounding atoms. Now SO bond order is equal to, okay, surrounding sum of the bonds 2 plus 2 plus 1 plus 1. Tell me value. 2 plus 2 plus 1 plus 1. So surrounding atoms, how many atoms? 4 atoms. So now here 6 by 4. 6 by 4 means 1.5. What is the bond order? 1.5. Understood? So these are the important molecules: carbonative, phosphative, perchlorative, sulfate. Mostly these four structures asking every time for NEET exam and JEE exam also. Okay, one question. Okay, determine CO bond order in formate ion. Determine CO bond order in formate ion. Okay, so formate HC double bond O minus. SC double bond O minus. So many students, what they are doing, so about trick is there na, some of the surrounding bonds by surrounding atoms. Here total surrounding bonds 4 by surrounding atoms 3. So 1.33. That is wrong. Here particularly asking, which is asking here particularly CO bond order, not CH. Here CH no need to include. Okay, CH not include. You no need to include CH. Here asking CO bond order. Understood? CO bond order we can include. Understood everyone? CO bond order we can include. Two COs we need to consider. CH no need to include. CH no need to include. This CH. But here asking CO. So that's why surrounding bonds means here we can take 2 plus 1, 3. 3 by these two atoms. 3 by 2. So 1.5. Understood or not? So or otherwise the resonancy forms also we can write. Based on resonancy forms also we can determine CO bond order. So CO bond order. How many resonancy forms here? Only 2 resonancy forms possible. How many resonancy forms possible? 2 resonancy forms possible. So how many resonancy forms possible? Only 2 resonancy forms. So you can take 2 fixed atoms. Okay, you can take 2 fixed atoms. So bond order is equal to total 2 resonancy forms possible. Okay. So bond order is equal to CO bond order is equal to CO bond order is equal to in between 2 fixed atoms 2, here 1, 2 plus 1. Total resonancy forms 2. So 3 by 2. 3 by 2 means 1.5. 1.5. Understood or not? So now CO bond order, simple trick, that is sum of the bonds around the central atom means 2 plus 1 only we have to take. CH here particularly not asking CH, CO asking. That's why 2 plus 1 by 2, 3 by 2, that is 1.5. For example, in this molecule, CH bond order asking. That CH bond not involved in resonancy. CH bond. That's why bond order 1. In any molecule, there is no resonancy, then bond order also fixed. If there is resonancy, then electrons, non-bonded electrons and pi bonded electrons delocalization takes place now. That's why bond order changing. For example, electrons, non-bonded electrons, pi bonded electrons delocalizing in between double bond, single bond, 2 atoms, in between 2 atoms. Bonds delocalizing in between double bond, single bond means in between 2 and 1. It is 1.5. Understood? What is the bond order definition? Number of bonds in between 2 fixed atoms is known as bond order. But for polyatomic ions, due to resonancy, their bond order changing. Understood? So this is a very, very important concept. Understood? I hope everyone understood this concept. Thank you. Thank you so much.